Good day, everyone. So today we are going to be seeing how to simulate CMOS AND gate in uh, LTSpice software. So first we will just take a look at the AND gate construction using CMOS. So here we can see that there is a pull down and pull up circuit. So here the pull down will be the logic of the circuit, and the pull up will be acting as our uh, high resistance, which will stop the VDD and the VSS, which will ideally be a ground, from being connected directly. So here we can see that the pull down circuit has a logic of A and B being connected in series, so that only if A and B are both connected to the ground, we will be having output of 0 here technically. So this will be a NAND gate. So if we connect an inverter here, we will be getting a AND gate as the output using CMOS logic. So let's move on to the LTSpice simulation. Now we are looking at LTSpice software. So in the software, we have to first click on a new schematic. So this will create a new schematic for us to build our LTSpice model on. So as we had seen, we had two MOS transistors in our pull down and two in our pull up circuit. So if I just put two NMOS in the pull down and two put PMOS but in parallel in the pull up circuit, I will be getting this is the basic skeleton of the diagram. So here I also need to make sure there is a VDD, and I need to make sure there are input signals. So here I will go and select the voltage. So here the voltage is typically 5 volts. So after this is done, I will just connect everything using the wire. So these both are in series, and this is in the parallel with the pull-up circuit. Let me just connect our source to the drain. So here I'm grounding the VSS. So this is our basic circuit. Now we have to give A and B inputs here. Now we can logically give 5 and 0 physically, but in this particular video, we are going for an approach where we want to see all the possible inputs and the outputs at the same time. So I'm going to give a waveform of two different frequencies to visualize the output. How we will do that is that we will again click and give two voltage sources. Now after giving two voltage sources, we will ground the particular sources, the negative of the sources, and the positive of the sources we will give a input port. For example, this is going to be my A signal, and this is going to be my B signal. Now here, if I click on advance and if I go to pulse, if I give V initial as 0, V on as 5 volts, delay as 0. Now we ideally want rise and fall to be 0, but LTSpice does not allow that. So let me put 0.001. So T on is 4 and the period is 8, means it will be on for 4 seconds and off for 8 seconds. So I will give this as that. Then I will go to advance. I will give another B also. I will give the same, but I will vary the frequency. Here it will be on for 2 seconds and the time period is 4. Now to view the output, I will have to give a output voltage node here. So that also I can go here and can put something like out, and it is a output terminal. So now I have to give the inputs, right? So again I will go to port and I will give A, and since I gave input terminal there, I will give input port here also. Same I will do for B also. I will give B as input terminal. Now to visualize the output, I will run the LTSpice. When I run, it will ask for how much time I should run this. So since I gave 8 as the time period, I will give 8 here also. Once I run it, I need to add the plot planes. So I need 2 plot planes. And here I will give VA, VB, V out. And here we have to give auto arrange by axis to see that it is arranged. We can see that when both are 1, the output is 0, which means it is a NAND gate. So when both are 1, the output should be 0. When both are 0, 1 or 1, 0 or 0, 0, the output is 1. So what we have done is we have simulated a NAND gate in CMOS logic successfully in the LTSpice. Thank you.